All right, so today we're going to complete Exploration 6.3 in class on Zoom. Thursday, you have the 6.2 points due, so those were what we finished up on Wednesday, so hopefully you can get those in ASAP. Always remember, if you miss some exploration points, you can either ask me to reopen those explorations, or you can email me screenshots of your explorations. I'm happy to look through those as well. Friday, we will start into chapter 7. Somebody just asked me about this. I realized yesterday actually that RAT 20 is actually RAT 21, so there is no RAT 20. I got messed up on my numbers, so RAT 21 is due. You didn't miss one. I just there will be looking at some points too. On Sunday, you have Exploration 6.3 points due, and I also want to point out that your final project is due Tuesday night by 11, the 28th. So I did get all of the results. So they're all graded. So you should be able to get on and see your grade and see the feedback.
Really badly.
Sorry?
You were breaking up like really badly.
Okay. Can you hear me now?
Yeah.
Yeah.
All right. So Zoom decided that we're using too much bandwidth. So they're putting restrictions. So sometimes I think when I'm projecting, you might not be able to hear me great, unfortunately. So just if you can hear me, I'm not running much on my computer right now, hoping that we can still get through this. All right, so I just a couple comments on the final paper, and definitely I welcome
Melinda, we can't really hear what you're saying.
Okay. Let me try changing my speaker here. Is this better?
It sounds good right now.
All right, we'll try with my headphones. Abstract is like a 1 to 2 sentence summary of each section. Your sections being the background, methods, results, discussions, and conclusions. Make sure you're making any changes based on the feedback that I gave on each part. That's kind of the purpose of giving that feedback, is so you can make those changes and your final paper reflects what those changes represent. Discussions and conclusions. So this is the new part that you need to add to the paper. So you need to write conclusions for each research question. So how much evidence based on your p-value and confidence interval is there for the alternative? So that's what we're looking for with a conclusion, is you're writing that's based on our p-value of 0.002, we had very strong evidence, and then write your alternative hypothesis. You do need to discuss that scope of inference and interpret the p-values and confidence intervals. You should also discuss limitations of your study and potential future research, and then end with a couple of concluding sentences that summarize what you saw. Then you're going to have your references and then the appendix. This is all one submission that gets turned into Gradescope by next Tuesday at 11 p.m. You do not have a quiz due next Monday. That quiz is going to be due on Friday the 1st. Any questions on the paper right now?
So for reference, are you just saying that you're going to want us to like compare this to other studies and stuff like that that had with like similar information?
The references here?
Mm-hmm.
The references is just a list of citations. Did that answer your question, Jason?
Yeah, I think so.
Oh, yeah. You already turned in the references. I just don't want them in the middle of the paper. They should be at the end. They shouldn't be with the background. is basically what
Right.
I'm implying here. Just make
That's
sure
fair.
that you're citing the work that you, and they're mostly going to just be, they should just be the papers that you referenced, like the, any articles that you were using in your background.
Kind of like the inspiration behind what you were researching kind of thing. Okay.
Correct. Any other questions? Okay, so today we are going to focus on the theory-based methods for difference in means. So we're going to do a 2-sample t-test and a 2-sample t-interval. So Monday, we introduced this exploration. So today we're going to focus more on the theory-based methods for this study. So just to kind of wrap up what we were talking about on Monday and to refresh your memory on what we're looking at, we were looking at the relationships between men and women. So we're seeing if there's a difference in true mean number of close friends for men and women. So remember, we can just we don't care about this pooled data here. So we had a mean number of close friends for men of 1.86. and a mean number of close friends for women of 2.09, seeing that observed difference of negative 0.228. That goes in over here to find our p-value. Notice that our hypothesized null is 0 because we're assuming that there is no difference in the true mean number of close friends for men and women. And we get a fairly small p-value, which says that we have strong evidence that there is a difference in the true mean number of close friends for men and women. We may have talked a little bit about whether or not we think this is practical. What do you guys think? Do you think this is a practical difference? Does it seem important to say that I have 0.228 more friends than somebody else?
No.
No, so it may not be really a practical difference here. So we talked about practical importance a while ago. We are seeing statistical significance. That could be due to the fact that we have such large sample sizes. So basically with class today, we're going to be looking at the theory-based methods to see, are we getting those same p-values, the same standardized statistic, same confidence interval using theory-based methods versus simulation. So here I just have another example of an interpretation of a p-value. This is pretty much a guarantee that you're going to have some sort of interpretation on the final of the p-value, because understanding what that means is really important. I have this one color-coded to talk about that we're looking at this probability based off our p-value of seeing our sample statistic or more extreme in this case because it's a 2-sided test, then under the assumption that the null is true. So just making sure that you have some practice with interpretation of p-values. All right, so we are just going to jump right into the exploration. Question 9. 9 through 11 are really just looking at, well, what happens if we did this? What happens if we did this? How will that affect the p-value? So this is taking you back to thinking about some of these concepts we learned earlier in the semester. So I'm going to go ahead and put us into breakout rooms. Is there any questions before we go into breakout rooms? And we are just doing questions 9 through 11. All right, let's just check to make sure that you guys can see my screen.
Sure can.
All right. All right, so looking at questions 9 through 11, so we're just looking at what affects the p-value. So if we have a larger difference in means, meaning that our statistic is farther away from 0, what would happen to our p-value?
It'd shrink.
Yeah, we're going to have a smaller p-value. We have more evidence against the null. How about increasing sample size? What effect does that have on the p-value?
We also said that it would shrink,
Yep,
decreasing the variability.
p-value. Right, we're decreasing our sample-to-sample variability, so we have a smaller p-value. How about increasing the sample standard deviation for each group?
We said it would increase the p-value because there's more variability.
Right, we're going to have more variability in our study, so we'll have a larger p-value. Good. So this is just kind of some review of some concepts that we learned earlier in the semester, but it applies to any type of study that we're looking at. So what we're going to focus on today is our theory-based tests for a test of significance for two means. So when we have a quantitative response variable, we're going to use the t-distribution as our theory-based distribution. When our data was categorical, remember we looked at the standard normal distribution. So here we're using a t-distribution just like we did for a single mean. Notice that when we find our standardized statistic, we're always taking the value of our statistic minus the null. And our null value is 0 when we're testing for a difference in means. We're always assuming that those means are equal. And we're dividing by the standard error for the difference in means. So I want to point something out here. This does not mean standard error times x bar 1 minus x bar 2. It's not, there's no multiplication. This is just a variable, and it is this calculation right here. Okay, so we're not multiplying. We're just going to say, oh, that we're taking the square root of our sample standard deviation in group 1. So S1 is sample standard deviation in group 1. S2 is the sample standard deviation in group 2. And our sample sizes are the sample sizes of the two groups. There is an error on page 357 of your book if you have the hard copy. I think they've fixed it now in the online copy. But they have something weird with the second standard deviation. It's like the standard deviation of group 2 to the power of 1. So just make sure that you make that change in your textbook. So we are just taking our difference in means and dividing by the value for the standard error for the difference in means. Because this is a theory-based test, we need to check our validity conditions. As long as our variable has a symmetric distribution in each group, so if we look at the shape of the distribution for the sample, as long as they're symmetric, we can use the t-test. But if our sample sizes, or if they're not symmetric, then we need to look at our sample size. And if our sample size is greater than 20 in each group, then we just need to make sure that sample distribution is not strongly skewed. So this is the same condition we had when we had a single mean test, but now we just have to check for both groups. All right, so when we estimate, find our confidence interval for the difference in true means, we're taking our statistic plus or minus the margin of error. The margin of error here for the difference in true means is going to be our multiplier, which will always be given, times the standard error. And notice that standard error is that same equation. So this is what we're plugging in for this entire value. Again, it just means standard error of the difference in sample means. So we're going to also estimate, find our confidence interval for the difference in means today. Any questions on these formulas? Everybody still hearing me okay?
Yep.
Yes.
Thanks.
I took a poll and the general consensus is there's no questions.
Okay. Thanks, Sarah Eden. All right, so I'm going to put you in your breakout rooms for quite a while here, working on questions 12 through 19. I do want you to make two changes. So if you need to take a picture of this screen really quick or something, just so you remember these changes. Question 12 in the text doesn't have you using the formulas. It just has you clicking things on the computer. I want you to use the formulas so you have practice doing so. So in question 12, you are going to use the formula to calculate the standardized statistic and then work through the rest of the questions, 13 through 16. You can follow those directions just to see how we would use the computer to find the p-value. Then you're going to do 17 and 18. And then in 19, when you calculate the confidence interval, I don't want you to use the computer again in part B. I want you to use the formula and use a multiplier of 1.964. That's the appropriate multiplier to use to find the confidence interval. So these are the two changes you're making, but you are doing questions 12 through 19. We'll be traveling around the breakout rooms, myself and the aides. We can move ourselves around to help answer questions. So everybody understand the two changes I want made in this exploration?
Yes,
Thanks, Aiden. I appreciate that you're taking another poll for me there.
no problem.
All right, so I'm going to open up those breakout rooms and we'll check back in a bit. All right, so I think I got everybody back. Are you guys able to see my screen?
Yep.
Okay. So looking at our calculations, I know a couple people said that they had some problems with this calculation. So the 1.78, so that's my sample standard deviation for group 1, so for the min. And we have to make sure we square that value, and then we're dividing by the sample size for group 1 for the min, adding the sample standard deviation for group 2, the women, divided by its sample size. And we get a value of 0.093, so that's the standard error. Notice we're dividing the difference then in means, the -23, divided by that standard error, and you should have gotten a standardized statistic of close to -2.473. So I know a lot of people were having some issues with the applet. Sometimes when it's a really large sample size, it gets hung up. So I want to show you quickly another option for finding the p-values for theory-based. I know we're pretty much out of time, but we'll just finish this up really quick and then we'll talk about these questions in class on Friday as well. So we'd click on this theory-based inference and choose two means over here for this scenario. And then you can paste in the data or you can just put in the group mean, sample size and standard deviation for the men and the women. So down here under the distribution over here, we're doing a two-sided test. We can see that test statistic of -2.47 and the p-value. So this is another option for finding that theory-based p-value. All right, I do realize we're out of time here. We'll go over those last couple questions in class on Friday. We're just asking that you complete through question 19. So if you have a chance to finish out those questions, we'll talk about them in class on Friday and then start into 7.2. Talk to you later.